So we are all set up to get Joel up here and present to us about Jewish astronomy and the Hebrew calendar. Come on up, Joel.
Thank you. All right, thank you, Paul, for the introduction. My name is Joel Dick. I've been a member of RASC for coming on to, I don't know, 8-9 years probably now. I'm as a amateur astronomer, so this talk's not going to be super technical. I tried to balance it out a little bit to make it a bit recreational, but apologies if I do get somewhat technical. How do I advance slides? Is it just the arrow? There you go. All right, so this talk is about Jewish astronomy and the Hebrew calendar. So the Jewish history is full of very famous astronomers. There's a very intimate connection between the Jewish religion, Jewish culture, and astronomy. I don't know how many people here are aware of that, but historically, a lot of the famous astronomers have been Jewish. And just to illustrate that point, the craters on the moon are all named after prominent scientists, and there are several that are named after historical Jewish astronomers. And I've highlighted a few of those over here. I'm not sure how clear the image here is, but if you look at that one down at the bottom, Zacuto is actually quite a, you can actually make it out on a clear night. The other ones are a little harder to see. But Aben Ezra is named after Abraham ibn Ezra. I don't know why the name was changed to Aben Ezra. He's pretty famous. There's a, he's more better known as a poet, medieval poet, who lived in Spain and France and other areas. The second one is Rabbi Levi ben Gershon, who's also quite an important figure. And that third one, Zacuto, is Abraham Zacuto, who actually played quite an influential role in the history of astronomy and naval exploration. So we'll get to that in a minute. All right, so let's just to give you a little bit of background on the different figures. I've skipped Aben Ezra. He's quite, he's the oldest on this list. I didn't have that much information about the work that he did, except just that he wrote several books about the Jewish calendar, about mathematics, about tables astronomical tables of times and dates and so on. But Levi ben Gershon is actually quite an interesting one. He was born and lived in Provence, France, and he translated, and he was very much influenced by Aristotle and Averroes, and he made even some corrections to some of the works of astronomy of Aristotle. Averroes is a famous Islamic astronomer, medieval astronomic, who was also very influential. So a lot of the distances told me the Ptolemaic model of the universe, of the Earth in the center with the several spheres around it. Ptolemy gives a measurement for the distance of the fixed stars, and which of course is very inaccurate in today's measures. Rabbi Levi made an update to that, which is slightly more accurate. Again, it's not accurate by any means in modern terms. But the most interesting thing about him is that he's the inventor of Jacob's staff. So until then, the main instrument that was used and you can see this is a stamp that was put out by the government of Israel a number of years ago. You can see that big ship there in the background. So the main instrument that was being used in naval navigation was the astrolabe, which is a little disc, and you turn the disc to see the height of the sun, to tell where you are in latitude. So what he came up with is actually quite a simple concept. All it is just a bar in the middle with a stick at the end, and as you move the stick further and closer away, you get a bigger and smaller angle, and there's little ticks along the middle bar that shows you degrees. So it's basically a trigonometric tool. It's sort of like a protractor almost, that tells you the angle between the horizon and any given star, and that's thanks to Levi ben Gershon. The third name actually on the list is Abraham Zacuto. He lived far later. This is 1452, so this is already 15th century. He was not in Provence, France, but he was in Spain, which is Castile and Leon. To give you a little bit of a historical background, the Jewish community of Andalusia and Spain and the Iberian Peninsula goes back very far. They flourished under the Islamic rule, and a lot of those Jewish astronomers were working for a lot of the royal courts under the Islamic rulers, and they understood Arabic. A lot of the old works of astronomy, especially, for example, Ptolemy, was translated into Arabic. We'll get to that in a minute. So a lot of that knowledge from Ptolemy was then brought over to the Christian world as Spain was reconquered by the Christian rulers. A lot of those old Jewish scholars who had translated into Arabic, the Christian scholars did, or the Christian kings and so on, did not understand Arabic. So a lot of that translation work then got done by the Jewish astronomers that were working in that court. So this Abraham Zacuto was a royal astronomer in the royal court under the kings of Castile and Leon. What happened in the 1470s, I believe it was, is Spain was unified. The king of Aragon or it was the queen of Aragon and the king of Castile and Leon, Ferdinand and Isabella, who were famous for being the king and queen who had sponsored Christopher Columbus's voyage to America. After unifying Spain, they expelled all the Jews from Spain. So a lot of them fled to Portugal. A lot of them fled to the Netherlands or other areas in France or Germany, which had also large Jewish communities. This particular astronomer, Abraham Zacuto, he fled to Portugal, and under the king of Portugal, who was King John II, he was the royal astronomer. And actually, it was before he fled that he had actually produced tables of where various, based on the elevation of certain astronomical objects, you were able to chart exactly where you are in the world, at least on in terms of latitude. Longitude is another story, which a lot of you might be familiar with. So this is just to show you the plate I show on the bottom, on the left here, is the Alphonsine tablets, which is King Alfonso of Spain. This was done much earlier in the 1270s, again, based on older translations that were done throughout the medieval times. Zacuto's almanac, and actually when he wrote it, it wasn't called almanac, it had a Latin name. Or actually, almanac is the Latin name. When he wrote it in, I guess it would have been Arabic or Hebrew. I think he called it Chibur Hagadol. It was called the Great Work, or the Great Work, I think it was called, and then it was translated later into Latin. And this was essentially the authoritative source that was used by naval explorers for including Christopher Columbus. And actually, Christopher Columbus names Zacuto in his diaries, or actually in a letter. Everybody knows the story of Christopher Columbus and the eclipse. In his accounting of it, he says that it was Zacuto who predicted that. So it was thanks to Zacuto that Christopher Columbus was able to know exactly when that eclipse was happening. All right, so let's sort of explain, where does this go back to? Where does the affinity that the Jewish culture and Jewish religion have for astronomy, where exactly does that come from? So I mentioned one factor. One factor was the fact that a lot of the Jewish scholars thrived under Islamic scholarship, which were the inheritors of the great banks of knowledge, of Greek knowledge. After the Library of Alexandria was burnt down, a lot of that stuff went to the library in Baghdad. So Ptolemy's books, those all inherited while Europe was still in the Dark Ages. So the Jews were sort of the custodians of that, and they were the go-between between the Islamic world and the Christian world. So that was one factor, that because they understood Arabic and they also wrote a lot in Hebrew, and that's one factor. But let's see if we can trace this back. So to the Bible. All right. So in the Bible, there's not that much mention of astronomical details. But one interesting reference, which if you ever go down this rabbit hole and Google astronomy in the Bible, this is probably where you're going to end up. So this is the book of Job, and there's several astronomical objects that are mentioned. So I'm going to read it in Hebrew here. Osa ash, ksil v'kima v'chadrech teman. So he makes, this is referring to God, he's the creator of ash. So ash is one astronomical object. Again, this is debated by scholars exactly what it's referring to. Ksil and Kima. And then there's a second reference in Job. And this one's more interesting because this gives a few more clues to what the identity of these objects. So Kasher Madanot Kima. This is God speaking to Job, saying, Job questions God. Job, the story of Job was he was a guy who was given tribulations by God, and he lashes out and he says, why is God giving me all these troubles? So then God answers him and says, do you understand my ways? And the chapter 38 goes through all the different natural phenomenon that God creates in the rain and the ice and storms and all that. And in there is a reference to astronomical phenomenon. And God is sort of asking Job, are you able to understand my ways? Are you able to tie or bind the madanot are chains of kima, or the moshkos are the ropes of Ksil? So the translation it uses here is Orion. Ksil in Hebrew means the fool. Right? That's what Ksil is, the fool. And I always found it interesting when you look at Orion, he sort of looks like a fool, and he's got that belt, which is sort of his bind. So I think Ksil is referring to Orion, and I think most people would agree. Hatotzi Mazarot Be'ito, that's something else. Mazarot is another one. And I find when this is Ayish al Bnei Tanachim, can you console Ayish on her children? So I always tie this to the legend of the Seven Sisters, right? Which is sort of like the mom and the dad chasing after all their little kids. I don't know if you've ever seen a picture. I should have put a picture of the Pleiades in here. But the Pleiades, I think this might be referring to the Pleiades. And the Talmud, which is dates a little later. This is the Talmud from about I would say, written anywhere between the 2nd century and the 6th century, has a legend which it ties to the story of the flood. And I'm just going to read the passage quickly over here. It was taught in the 600th year of Noah's life. In the 2nd month, that's in the Bible, that's in Genesis. The flood started, that the fountains of the deep opened and the world started flooding. That was Noah's flood. Rabbi Joshua says that day that the flood started was the 17th day of Iyar. Iyar is the month following the spring equinox. It's the day on which the constellation Kima, so we don't know what Kima is. Ksil identified as Orion. Kima is a lot more controversial. We don't even know, is it in the southern sky? Is it in the northern sky? What happened was it sets during the day. So we're about almost coming into spring now, and Orion doesn't really set during the day. So certainly I don't think it's talking about Orion. It's probably referring to another constellation in the south. But this is somewhat controversial. And the season that the spring diminishes and increases heat. We're going into the summer. So Kima is associated with a constellation that takes out the spring and brings in the heat of the summer. So because the world changed their actions, the Holy One changed the act of creation, which means he distorted nature, and he caused the constellation of Kima to rise during the day, and he removed 2 stars from Kima. So the constellation rose at a different time of the day than it was supposed to rise, and that's what caused the flood of the world. So there you have it. This is part of the legend of Noah's flood. This is Talmudic, which is centuries later, after the Bible was written. Now, this is from a different book of the Talmud, where there's a lot of clues in here about exactly. I don't want to go too much into this because I don't want this talk to take too long. But you do have I'm going to read a little bit over here. This passage here is referring to comets, and there's a very interesting passage over here that on comets you say a certain blessing if you see them. So Shmuel, who is one of the scholars of the Talmudic era, so we're talking about the Persian era. This is after the Roman conquest of Judea. A lot of the Jewish community, the center of the Jewish community, shifted towards the Persian Empire, which was not under Roman rule. They were ruled under the Parthians. So that's in the area of today, Baghdad, Fallujah, and so on. There were large Jewish communities over there. One of the scholars in those Jewish communities was Shmuel. He was about the beginning of the Sassanid era, which is, I would say, the 500s AD, or a little earlier than that, actually, 200s AD. So he says that comets, he says, the paths of the sky are as clear to me as the paths of my city, Nahardea. Nahardea was the city he lived in, and he says the paths of the sky. This really resonated with me as an amateur astronomer. As you get to know the sky, you turn left at Orion, you get to know it. It's almost sort of like, there's that little alley, you go down that street there, and on the third door on the left, there's that little shop. This is something that I'm sure astronomers probably appreciate when you're trying to find a little galaxy or deep sky object. When you get familiar with the sky, you can find your way around, almost like finding your way around the streets of your hometown. I'm going to skip through here. Okay, there you go. So there it makes reference to those constellations, and it brings two biblical references. One where it lists Kima and then Xil, and the other one's where it lists Xil and then Kima. Chain the binds of Pleiades and so on. There you go. Shmuel says it's approximately, okay, so Kima, that's the one that we're dealing with. He says that comes from the Hebrew term kemea, like 100. So it's sort of a bit of a play on words. Some say they're concentrated and some say they're dispersed. So that sounds a lot to me like it's describing a star cluster. So that's where I get it, that it probably referring to, now Aish is the one that I suspect was the Pleiades. So it's either the Hyades or it's referring to some other star cluster that was very well known. All right, so here the Talmud is trying to identify what Aish exactly is. Here it is. So some say it is in the tail of Aries, and some say it belongs to the head of Taurus. That's exactly where you can find. Now, the tail of Aries would be the Pleiades, and the head of Taurus is probably the Hyades. So there you have it. So here I've put it out based on the several clues that we have. I'm not going to go too much into it, just because I want to get on to the next topic of the talk. But this is a very interesting discussion that a lot of, and here I have several references. There was this paper, Ehud Bar Sinai, if you want to check it out, he's got a whole paper on trying to identify what these various references to these astronomical objects in the Bible are. And there you have some more references over here. All right, so the next little subtopic I'm going to discuss is the Jewish calendar. So the biblical references are there, and the Talmudic references are there, but they're quite sparse. That's not astronomy. We don't get from that to Zacuto and Levin ben Gershom. Here's where it gets more interesting. Now, the third factor that I'm going to throw out there of why the Jewish culture and religion have always been very strongly tied to astronomy has to do with the calendar. The Jewish religion centers very much around the events during the year, the holidays of the year, and which is based on the Jewish calendar. Now, the Jewish calendar, here I'm just giving a little bit of a timeline just to give perspective, because I keep throwing out the terms biblical, Talmudic, and so on. So just to give you an idea of what era we're talking about here, the Old Testament books were written throughout the pre-Greek times. Some of the newer books that were included in the New Testament that are not included in the Old Testament, such as the book of Maccabees, that's the Maccabees who was a revolution against the Greek rule over the province of Judea. So we're talking already Greek era. Those books were excluded from the Old Testament. So the Jewish Old Testament sort of ends at around the Greek conquest, about Alexander, the time of Alexander the Great, which is about 300 BC. Everything past that, what we're talking about is what I call the Talmudic era. Those were the scholars putting down those passages that I read to you earlier. And some of that was written in Judea, Roman Judea, and then a lot of that scholarship shifted to Babylon, Persia, which is where the rest of the story comes in, which is then eventually becomes conquered by the Arabs in the 600s by the Muslim conquests of Iran and Iraq. And that's where the Jewish culture then starts to shift towards more of an Arabic culture. And then from there, it spreads to Andalusian Spain, and then from there into the Christian world. So that gives you sort of a bit of a background. The first Arabic translation of Ptolemy was actually made by Shal ibn Bashar al-Israeli. So clearly, this first translation of Ptolemy, he was Iranian. He lived in the southern part of Iran, and eventually he came to Baghdad, and he was also he was the court translator in the royal library and so on. And he was the first one to do a translation of Ptolemy's works. So again, a Jewish astronomer is responsible for Ptolemy's works basically coming down to us through the library of Baghdad. And then when you start getting to Andalusian Spain, you get to the Toledo School of Translation, and that was extremely influential. the Alfonso tablets and charts and so on and so forth. So let's talk about the calendar. Okay, so the Jewish calendar is based on, mostly is a lunar calendar, right? With some adjustments made to update it toward for the solar calendar. So there's months added to extend the calendar. So let's see how exactly that works. So the synodic month. Synodic month means the point in the month when the moon is a new moon to when the next new moon. So a new moon happens when the sun and the moon are in conjunction with each other, and the moon passes from the, I guess, to the right, east, west. Let's see, it would be, we call that east, I guess, to the west of the sun. The moon is moving about 13 degrees each night. So from one month to the next month is synodic month is about 29.53 days, which is slightly longer than what we call a, I think it would be called the sidereal month, which is when the moon is from the same place against the fixed stars. But because the sun is also moving with respect to the fixed stars, the moon actually has to go an extra constellation. Each month, the sun is in the next constellation over, so the moon would have had to make its way around all 12 constellations, plus the next constellation where the sun had moved over. So that's what we call a synodic month. And that's 29.53 days. And based on the Jewish astronomy, Maimonides, who was another scholar who lived in the 1100s, he gives that as 29 days, 12 hours. There you have the 12 half days. And then you have a little bit more, slightly a fraction of an hour, almost an hour. And he gives it in 10/80th of an hour. And this is very close to modern astronomical measurements. This is within, you can see, 0.0002%. So this is extremely, extremely close. It's actually quite remarkable how close it is. I'm going to go here if I can find the passage here. This is here. This is what I found online. There's a very good. I put it in the reference. This is a translation of Maimonides. So he writes, day and night are 12 hours. Here it is. An hour is divided into 1080 units. The reason is the number is chosen because it can be divided into halves, fourths, eighths, thirds, sixths, ninths, tenths, and so on. So everybody knows 360 degrees is a very convenient number to use because it's divisible by all the different numbers. It's anti-prime. So 1080 was also used because that was able to give very precise measurements, as we see, as precise as 0.0002%. So 1080 is an extremely, that just makes it a little confusing when I was doing research on this. It's very confusing to talk in 10/80ths of an hour instead of minutes. In my mind, I was like, how many minutes is that exactly? And I'm using decimals too. I'm using 0.53. So in my spreadsheets, I had to constantly do those conversions from what's called halakim parts or fractions of an hour down to hours. So according to this calculation, interval to one conjunction of the moon and the sun to the subsequent conjunction, according to the mean movement, is 29 full days, 12 hours of the 30th day. That's an extra half a day. And 793 units of the 13th hour. Right? This is the interval. So that is what the entire calendar essentially is based on. So once we have that magic number, we can then figure out the rest of it follows. So months will alternate between 29 days and 30 days. So if a month is 29 days, if you start a month theoretically on a new moon, if you give it 29 days, your new moon is not going to be really until a little bit later. So you've lagged a little bit. So what you do is the next month, you make it 30 days. You catch up. Now you're a little bit ahead. And then you keep shifting back and forth. So sometimes you get 29 days, some days you get 30 days. That's 11-day difference from the solar calendar. All right. So because the solar calendar is 354 days per year is 12 lunar months. If you do the multiplication. We're 365 days in the solar calendar, your 11-day difference. That's where extra months are added to adjust it to the solar calendar. So every few years, you get an extra month. You get 13 months instead of 12 months. All right. So historically, going back to, this is the early part of the Talmud. This is the part of the Talmud that was written, say, in the 2nd, 3rd century AD. So before, this was already the part that was written still in Roman Judea. This was before the Persian era. This is what's called the Mishnah, which is the original part of the Talmud, writes that 6 months of the year, there were 6 given months because those are the months that have holidays in them. Emissaries would go out to all the different cities of the Jewish diaspora, all the way to Persia, all the way to Babylon and even Asia Minor and so on, to give them the news about whether or not the month was made 30 days or 29 days, as I discussed. It's 30 days or 29 days. It was adjusted back and forth. Right? And it lists, Passover. It was done in Iyar due to in Nisan because of Passover and all the different holidays. It lists over there. Those were the months. So the months were established by the High Court in Jerusalem, which sat in Jerusalem. It was the council that was responsible for determining whether or not the new moon, should be declared on the 30th day or on the 31st day. Right? So that worked by if the moon was sighted. So the moon was sighted. There were witnesses that actually had gone up onto a hill, had seen the new moon. That's actually a fun activity as an amateur astronomer. I've done this once, trying to see how early in the month you can actually make out the new moon. That's quite a bit of fun, actually. So you got to get it in the day. So you go on like the day right after the new moon happened, and you go out towards the evening time when the sky is starting to dim, and you look for the sun, and then you look sort of a couple of degrees to the left of the sun, and sometimes you can make out the new moon, sometimes you can't. Right? And if you can spot it, that's quite a bit of fun. So usually we're trying to spot things in the dark sky. Here we're trying to spot the new moon in a really bright sky in the middle of the day. And if you can spot it, once you get it, it's really quite amazing. Sometimes it just looks like a little cloud even. But that was very important back then. Back then it was important because they had to know whether or not the new moon should be made. So it's very easy to manipulate this, right? It's very hard to see. If they needed the month to be long, they needed it to be 30 days because they knew based on their calculations that the new moon wasn't going to happen, or you needed to extend the month by a day. They would just say, well, we're not accepting testimony. Right? And it's like, well, too bad. Nobody saw it. And this month's going to be a 30-day month. And if they needed it to be 29-day month, they would do everything they can to try to see it. And they were, okay, people would come. There's even a story in the Talmud where 40 people came and they had to house them in a courtyard, and they would put a meal for them. They would make them do as much as they can to encourage testimony because they really needed this month to be a short month. Now, the same thing, that council would also be responsible for determining when a new month was added. And that was determined based on more seasonal things. That was done every couple of years. If it was already not the spring equinox, if the spring equinox is not yet for another month off, but the Passover holiday, Passover is in Nisan coming up. Passover is in a few weeks, is a spring holiday. If the spring equinox hadn't yet come, they'd add an extra month. And coincidentally, this year is actually one of those years where there was an extra month added so that we can push off the spring equinox. Easter this year was actually just last week or this week. And that was usually the calculations of Easter, which were also based very much on these calculations, are usually aligned with Passover. This year, Passover is an entire month after Easter. And the reason is because the Gregorian calendar, which what the Easter calculations are based off of, hadn't added a leap year this year, went for this month's new moon for its calculations, while the Jewish calendar added a new leap year, so we're a total month. Next year will be 11 days closer, and then we'll sort of bridge the gap until the next leap year comes in. So all this was, and here's an interesting story. Rabbi Gamliel, he was the chief. He was the chief of the court of Jerusalem. Had a chart, a moon table, in his chamber, and when people would come in to testify, he would show them the various images of the moon, face looking in this direction, in that direction, and he'd ask them, what did it look like? How big was it? And that way he'd be able to find out if they were lying or not. If they'd say it was facing this way, he knew that that's not the new moon, that's the old moon, right? So did you see this form or did you see that form? He would ask them. So there was an incident in which 2 witnesses came, and they said, we saw the waning moon in the morning in the east. And the same day we saw the new moon in the evening in the west. So Rabbi Yochanan ben Nuri, who was another member of the court, said they are false. That doesn't work like that, right? That's impossible. So when they arrived in Yavna, which is where the court was sitting after Jerusalem was conquered by the Romans, the court had moved to another city called Yavna. Rabbi Gamliel, he accepted their testimony. Why? Because he was trying to get that month to be the new moon. So he said, well, maybe they meant this, maybe they saw clouds and they didn't really see it. So you had sort of an argument between these 2 rabbis of the court, whether or not we're going to accept these witnesses, whether or not we want this month to have an extra day or not. All right. This is another passage, and I'm not going to read everything here because I don't want this to take too long. What time do I have? I don't know how much time I have. Okay, I better wrap this up soon. All right. Here's another passage of Talmud where it says that the full months, we don't want to have more than, you don't have less than 4 in a year, and you shouldn't have more than 8 in a year. So on average, you would have 6 full months, 6 half months, because it's about 29 and a half days. So about half the months would be full, half the months would be deficient. But sometimes you'd have less, sometimes you'd have more. To have less than 4 full months would be too few, because then the next year's the new year would fall out too many days away from the actual astronomical new moon. All right, so this is what months were manipulated to keep holidays. Now, here's another passage in the Talmud which explains why these days would sometimes be added. Sometimes these days would be added because you want the holidays to fall out on certain days of the week. All right, so this is the story. Ula, who was also one of the scholars a little bit later in the history, he came to Babylon, and he said, this year the court in Jerusalem, he came from Jerusalem to Babylon, and he told them that they made this month a full month. Right? And he says, do you guys know, do my Babylonian colleagues understand how much the benefit that I've done for you by adding this extra, by making an extra day? Why? So what was the benefit that they had gotten adding the extra day? So some say it was mishum yarkio, is the vegetables, they shouldn't spoil over the holiday. They'd have to pick their vegetables. Then they didn't have refrigeration. If they'd have to pick their vegetables before the holiday, and you'd have the holiday and the Sabbath falling 2 days in a row, you'd go 2 days without fresh vegetables, and the vegetables that you picked on Friday would spoil. And some say, Rav Acha bar Chanina Amar, the other scholar says, Mishum Masiyah, it's the dead, the bodies of people who died. You'd want to bury it that day, especially in Babylon or in Judea. The weather was different, and the bodies would start to smell. They weren't able to bury them on the holiday or on Sabbath. If you'd have the Sabbath and Yom Kippur falling 2 days in a row, you go 2 days without burying the dead. That's no good. Right? So that's why they would add Elul, the month before the New Year, and Yom Kippur. That's the one that they would try to add or detract from, because that will determine when Yom Kippur will be. So we don't want Yom Kippur to be on a Sunday. We don't want it to be on a Friday. Also, the other holiday in Tishrei, which is the first month, is the holiday of Shmini Atzeret. We also don't want that to be on, or actually Hoshana Rabbah, the day before. We don't want that to be on a Saturday. So there's 3 days of the week that we don't want those holidays to be on. So they would just add an extra day, whether or not the new moon happened or not. So at a certain point in history, this became very inconvenient, especially since the Jewish diaspora started spreading throughout the Roman world to other Roman provinces, right, such as Gaul and Spain and so on. So what happened is that once you start getting into the post-Talmudic era, they needed a fixed calendar, which means they had to be able to calculate it without witnesses having to come and emissaries be sent out. They needed to have tables to tell them, this year, these are the days, this is when the new year is going to be. So it's attributed based on the consensus is that sort of around Hillel II, who was the patriarch in Judea at the time, at around 358 AD, which by that point was actually post-Hadrian. Hadrian renamed the province to Palestina. So Hillel was the patriarch of Jerusalem. He is the one who basically determined that, you know what, we're going to stop this system of testimony and witnesses, and we're going to start using a system of just a fixed calendar. However, there's clues, there's little this and that were worked out. Certain days of the week did work, certain days of the week. The actual system that we have today, Al-Khwarizmi, which is a famous, our term for algorithm is named after him. He wrote on algebra. He was a very famous Islamic scholar who lived, again, in Baghdad, in Persia. In 823, he describes basically the system that we have today. In this presentation, I've based it off of Maimonides, which I read to you earlier. He goes on for several chapters explaining exactly the system. But this dates actually before Maimonides. Ibn Ezra, who I mentioned earlier, had written a whole book on the Jewish calendar, and he was in the 1100s. So this system had already been in use for a couple hundred years. So the first thing that we're trying to do by fixing the calendar is making sure to figure out when these extra months will be added. That's important to make sure that our spring equinox lines up with our Passover holiday. We don't want every year to be 12 months. 12 months, we're going to lose 11 days each month. Eventually, like the Islamic calendar today, for example, Ramadan sometimes is in the spring, sometimes is in the winter, because the Muslim calendar does not add these extra months. So you end up getting a drift in the month of Ramadan. Sometimes it's spring, sometimes it's in the summer, winter. The Jewish calendar, we get these added months so that the Passover holiday is always in the spring, like Easter. So the calendar they settled on was what was called the Metonic calendar. Meton was an ancient Greek astronomer from the 1st century. Actually, not ancient Greek, that was Roman era Greek, but that was, I guess, Roman Greece. This was somewhat, I guess, probably the era around Ptolemy. He had calculated that the solar year, what we call the tropical year, 365.2422 days. Here's the chart. I did it myself on a spreadsheet. Meton did not have that benefit. But if you take a look at the number of tropical years, you assume that a tropical year is 365, the number of days. Here it goes. 365. One tropical year, number of days, 365.2422. And what you do is then you multiply. And the number of lunations, that's based on the 29.5 plus the 793 10/80ths of an hour. That's what I have in the second column. And if we keep extrapolating out, eventually, when we reach 19 years, you get 234.997. We're almost spot on for a whole number of lunations. Lunations is a synodic month. So that's a perfect number to choose. The number 19 was chosen by Meton, because that is almost an entire whole number, which means if I have 235 months in a 19-year cycle, I'm going to align with the equinox every 19 years, exactly. Okay? And it's off by 0.0024. If I use 235, it's actually slightly smaller. We're a little bit off. So it does drift a little bit, but over centuries. So here you have it. Here's our 19-year calendar. So year 3, year 6, year 8, year 11, year 14, year 17, year 19. Those are determined to be the leap years. And the rest of the years are 12 months. And we add those extra 13th month in every 2 or 3 years. All right, there you have it. That's our Metonic cycle. And this slide is just showing how it lines up with our Gregorian calendar. Our Gregorian calendar, we're also off by a few days over there too. Gregorian calendar works on a 400-year cycle. That does not take lunations into account, but you can see it still works out very closely to the Gregorian calendar is the adjustment made for leap days because of the difference in the 365 and a quarter is not really exact to the tropical year. The last adjustment that has to be made is what I mentioned earlier, the days of the weeks. Right? So this is the modification that was made to the Metonic calendar in order to adjust the years to certain days of the week. So going back to this slide, here we have it. Some years are leap years, some years are non-leap years. Some years will have, remember what we mentioned before, some years have 4, 5, 6, 7, 8. We said that the full months are not more than 4, not less than 4, not more than 8. What they actually settled on for this fixed calendar, as Maimonides described, is actually only 3 versions. Either we're going to have, I made a mistake there, that should be 12, that should be 13. The number of full months is actually not 4 to 8, but they've actually limited it to 5, 6, or 7. They kept it more simple. So either we have a year with 5 full months, 6 full months, 7 full months. So the number of days in the year can be adjusted anywhere from 353 to 355. And if we have a leap year where there's an extra month, the extra month will always have 30 days. Then you have that. Now, I added the modulo 7. Modulo 7, what that gives you is what day of the week the next year will be. So if the new year was on, let me pull the chart up. If the new year was on a Monday, There you have the modulos. There's the 3, 4, 5, 3, 4, 5, 5, 6, 0. That next New Year is going to be on Thursday, right? If it's a leap year and we use only 5 full months, it's on a Saturday. If we put 7, if we put 4, 5, or 6, if we put 5, 6, or 7, if we put 7 full months, then it's going to be on a Monday. Now I've crossed out some of these. That is to satisfy the other condition that I mentioned earlier. We don't want Yom Kippur to be on Sundays and Saturdays, and we don't want the other holiday to be on Saturday because we want to be able to bury the dead or because of the vegetables and so on. So certain of these year types we've eliminated. We've crossed it out. So those are unacceptable combinations of the years. And actually that year where you have a leap year, also starting on a Tuesday, we also don't use a full 6-month. So here you have the chart. So this is basically based on Molad. This is the new moon of the new year. We look at what time of the day it is, and we add either full or regular so that the next new year shouldn't be too many days away from the new moon. And this chart, which is described, also Ibn Ezra describes it, Maimonides describes, this is called the 4 gates. This is a little bit more complicated. This has to do with how we want 2 years certain in a row, based on whether the year is before a leap year, after a leap year, and so on. This gets very technical. I'm not going to dig too much into this. But this is sort of the other adjustment made to the Metonic cycle. So there you have it. Again, there's a lot more to be said on this, but I probably got to wrap it up over here. Here's your references. There's a lot more to be said here. But I'm going to just read a passage, actually, just to close this off. I don't have it on the slide, but there's a passage in the Talmud which I found very interesting, which reads as follows. There's an obligation on a person. So this is talking about there's a religious obligation for calculating seasons and zodiacs, which means all these mathematical calculations. Somebody actually, an astronomer, when a Jewish astronomer goes through the trouble of working out these calculations, they're actually fulfilling a religious duty, right? And it quotes a Bible verse. It says, "And you shall keep and you shall do the Torah, the rules of God, for it is your wisdom and your understanding in the eyes of the nation." Which branch of wisdom and understanding is appreciated by all the other nations of the world? That is the calculation of the seasons and the zodiacs. So the Talmud finds a biblical source that there's actually a religious obligation to calculate these things because it benefits all the nations of the world. As we saw earlier, the Jewish astronomers essentially opened up the entire world of astronomy from the Islamic world all the way to the Christian world. A lot of the stuff we have today is thanks to these Jewish astronomers who tabulated. A lot of this is very tabular. I wish I could put more pictures of, we're all astronomers, we like to look at the sky, but when you get into the minutia of it, a lot of it is really tabular data, and Jews are very good at that. We're very good at working out all those log tables and those trigonometric tables and so on and so forth. And this is where it comes from, really. This is where it comes from. It's calculations of the motivation here was the calculation of the calendar. So I hope that was informative, and thank you very much.
Thank you very much, Joel. Absolutely fascinating how things used to be done way, way back then. Don't go away. We may have some questions for you. All right. Any questions?
Questions
in the room? Okay, here we go.
So what is a tropical day? I believe in one of the slides you had it.
365.2522. So the extra 0.00, so 365.25 works out very nicely. So we have 365 days a year. The extra 25 we do by, this is the Gregorian calendar, and the Julian calendar did this as well, by adding an extra day, February 29th. It used to be an extra February 24th, because that was a certain holiday in the Christian calendar. But the extra 0.22 we didn't account for, and that's where you had the drift. The Julian calendar was drifting off. So Pope Gregory in the 1300s, I believe, added a whole bunch of days to account, and what he did is he basically took away some of those extra days, and every century, while every 400 years was a leap year. So the year 2000 technically is a century year, so should not have been a leap year, but the last 2000 was a leap year. We did have a February 29th. And if you do the math there, it works out to, if you look at the Gregorian calendar and you take that 400-year cycle and you divide it by the total number of days there are based on the number of, there's 303 regular years and 97 leap years. So do 303 times 365 plus 97 times 366, and then divide that by 400, you're going to get 365.2525, actually. It's actually 24, I'm sorry, it's 2422 or 2425, because we needed to take away some leap years. So we're actually a little bit less than 200, than the 0.25. So I'm sorry, apologies. So that's what the Gregorian calendar was there to correct.
Okay, I have another question. It's a little bit off topic, but if you're born on a leap day, how do you celebrate your birthday on the next year?
So
When?
the Jewish calendar, there's actually a leap month, right? And the way that works is that we always considered, so for example, this year, as I mentioned, was a leap year. So there were 2 Adars. Adar was the month before Nisan. The reason that month was chosen, because it's the month before the spring equinox. So we add the extra month to push off the Passover holiday so that it's after the spring equinox. That second one is the day that the holiday in Adar, this year there was a holiday of Purim. You might know what it's about. That's the holiday where people dress up. The story of Esther in Persia and the King Xerxes. That's a famous holiday in the Jewish calendar. It's a lot of fun. Kids go around, collect candies, and so on. That was celebrated in the second month of Adar. So in the Hebrew calendar, it's the second one that's counted. In the Gregorian calendar, if there's an extra February 29th, I don't know, do you celebrate your birthday on February 28th or March 1st? I would say March 1st. I don't know.
Or what do people do usually?
Individual choice. Okay, we got the question right here.
So is this why Hanukkah keeps jumping around in December, from late December to mid-December to early December? It's the 11 days cycling through, and then you add the month, which reboots it back to the end.
Yeah,
right?
so Hanukkah's in the winter. So so it's anticipating the extra month at the end of the winter before the spring equinox. So if we're in a year where an extra month has to be added, that extra month has to be added because everything is too early in the year. We're too early in the year, so we had to add that extra month. So usually in that year that approaches, put this slide over here, especially when we've gone, for example, year 4, 5, we've already gone 2 years without a leap year. So we're about 20 days off, right? The next year, you've added the extra 30 days. That next Hanukkah of the year 6, in year 6, Hanukkah is going to be in the winter, like where you see a number 72 over there, or 71. I'm not sure which one of those is the month of Hanukkah. Hanukkah is going to be very late in the year, but in the next year, year 7, it's going to be very early in the year. Ramadan doesn't do this, and if you notice, Ramadan each year will drift.
Question here at the front.
No, just a quick comment. And I thought figuring out Easter was complicated.
Yeah.
Boy, this is pretty fascinating stuff. Sure.
Yeah, I'll note actually about the Easter here we have year 1, 2, 3, 4, 5. So basically you take the year and you take mod 19 and you get the number, whether or not year 1. In the Easter calculations, that's called an there's called Euler's algorithm for calculating Easter. He calls that, or it's called the magic number or something like that, or there's like a special name. That number, the number of the year that you are, is a special number.
Have any questions online?
We have one comment online from Eric Briggs. In relation to the antiprime numbers, like 360 and 1080, Eric says 1080 is also a video resolution standard because it has so many factors. For the ratio 16:9, it's divisible by 9, but gives you 67.5 when divided by 16.
Yeah, that's interesting. And 1024 is a binary number, but it's close to the 1080. So sometimes you get some conversion factors over there. If you're using binary to encode your 1080, then you get a little bit of a. Sometimes you can get a little bit of a. Yeah.
You have a question here.
Hi, so I might have missed this, but how come having Yom Kippur on like a Friday or Sunday result in the dead not being buried for 2 days?
So Sabbath, which is every seventh day, no work is allowed. But to the Jewish, it's the Sabbath day. It's the rest. It's the rest day. So dead are not buried on that day. Yom Kippur is also a rest day. So that's a day for fasting. That's a day for prayer. Everybody goes to the synagogue. You're essentially praying all day. There's no burial of the dead happening. So if somebody would die late on, let's say, Friday afternoon, and you'd have Saturday, and then the next day would be Yom Kippur, they wouldn't get buried until Sunday. The dead body would have to be sitting around for over 2 days. And in warm climates, that would be pretty, that would not be nice.
Thanks.
Okay, so why don't we wrap it up here? Joel, very impressive. You seem to know this stuff inside and out. Very good.
There's a lot more to it. I'm just touching the surface.
Amazing.
All right, thank you.
All right, thank you again.